Okay, so I'm going to do one more video over the first derivative test. Just make sure you guys understand it. Um, you're going to need to know this before you work on the second derivative test because it will make it so much easier. It's basically the same concept, just doing it with the second derivative. So I want to make sure you completely understand this before we move on. Okay, so I'm just going to go through this pretty quickly, not waste too much time. So if you remember, for the first derivative test, just like its name, we're going to take the first derivative of its function. Okay, and then we're going to set it equal to 0 for zero product property. I'm going to factor out a 3x here. So then we have x minus 4, 0. This is going to be x equal to 4, because I just set that inside part 0. And this is going to be x equal to 0. Okay. Next, we're going to use these for our intervals. So we're going to start with the smallest, which is negative infinity to x to 0. Next, we're going to do 0 to x to 4. And then we do 4 to x to infinity. Oops, that's a wonky infinity. Okay, and just it goes by our smallest critical point. Remember, these are called our critical points. Next, we're going to find our test value that we want to use. It has to be in these intervals, so I'm going to use x equal to negative 1, x equal to 1, and x right here, we're going to make this equal to 5. Okay. And then we just plug it into our first derivative equation. So f prime of 1 is going to be equal to 3, or of negative 1, sorry. 3 times negative 1 squared minus 12 times negative 1. This is going to be negative 1 squared is 1, so this is a 3 minus 12, negative 12 times negative 1, so this is going to be a positive 12. And we know this is going to equal a positive number. It's going to equal positive 15. If we plug this in, f prime of x is going to be equal to f, actually we know it's going to be equal to the same thing here because, or no it's not, sorry. Let's see, 3, 1 times 1 squared minus 12 times 1. Okay, so then 3 times 1 is going to be 3 minus 12. We know this is going to be a negative number. This is going to be negative 9, I believe. All we need to know is it's negative 5. So here we're going to do 3 times 5 squared minus 12 times 5. This is going to be equal to 25 times 3. Let me check this because I'm not sure what it is. 3 times 25. This is 75 minus 12 times 5, which is 60. This is a positive number. This is going to be positive 15. Yes. So here this is a positive number, so it's increasing. This one's negative, so it decreases. This one's positive, it increases. So remember, this is the slope of your tangent line. You're looking at that point in your interval. And next we have to find our minimum maximum points. So to do that, we are just looking at our critical values and we plug them into our original equation. So let's do that really quickly. I'm going to keep these intervals up here. Okay. We are going to take f0 is equal to 0 to the third power minus 6, 0 squared plus 15, which is going to be equal to 15. And then f of 4 is going to be equal to 4 cubed minus 6 times 4 squared plus 15, which is going to be equal to, let's see here, 4 cubed, this is 64, minus 96 plus 15, so 64 minus 96 plus 15 is going to be equal to negative 17. This is our y point right here. This is our y point, and then our critical values are our x points. So the point here is 0, 15, and then our point here is 4, negative 17. We know our minimum point by looking at our y value. Whichever one has a smaller y value is our relative min. Which means this is our relative max. Which makes sense because if we're looking at a graph that looks like this, right? The x point kind of doesn't change. It's the y that you're looking at to see where the minimum is. You want the highest point and you want the lowest point. So we're looking to see what has lowest and highest maximum value to figure out which ones are max, which ones are min. I hope this was helpful to you. You need to know this before you go on to the second derivative test because it's pretty much the same thing, and if you have a good understanding of this, it will not be too difficult.